Hey you guys. So here we're going to do an example with using Coulomb's law. That is the electric force formula. So we want to determine the magnitude of the electric force on the electron of a hydrogen atom. So remember, hydrogen atom is made up of one proton and one electron. And so we want to see the force that the electron feels which is exerted by the single proton in this nucleus of the atom. So we're going to assume in this simplistic situation that we have an electron orbiting the proton at an average distance of 0.53 times 10 to the negative 10 meters. All right, so if we're looking here, we should identify that we're dealing with the electric force because it literally asks for that. All right, so we know that our electric force, the formula for that is going to be K, which is our Coulomb constant, times our first charge multiplied by our second charge divided by r squared. And that r is the distance in between those charges. Right? So this is Coulomb's law. So here if we're dealing with the variables, right? So electric force, that is what we're solving for. So I'll put a question mark there. We know K is about 9 times 10 to the 9th power, and it also has units, right? It has units of newtons times meters squared over Coulomb squared. Right. So then we also have the variables of Q1 and Q2, and those are our charges, right? So let's call Q1 here to be the, do you want to call it the electron or proton? I guess it doesn't really matter here, but we'll call it the electron. So Q1, the magnitude of that charge. So I'm not going to worry about whether that charge is positive or negative, right? So here we're just determining the magnitude, so I'm just going to use the magnitude of the charge as well. Right? So Q1 here is actually also equal to Q2, right? Because we're dealing with electron and a proton, and they have the same charge, just one's positively charged, one's negative. So this is about 1.6 times 10 to the negative 19 Coulomb. All right, and then we're also told R. I'm not going to rewrite that. I'm just going to say that's equal to R there. So this is just basically plugging and chugging now. All right, so we have our electric force. That's going to be equal to this 9 times 10 to the 9 Newton times meter squared over Coulomb squared. Q1, which is 1.6 times 10 to the negative 19 Coulomb. I could multiply that again, but that's the same thing as squaring, so in this case I can just square that quantity, just to save a little time. And we divide by our r of 0.53 times 10 to the negative 10 meters. Right, so, in doing this math here, we end up getting, so plug it into our handy dandy calculator, we get 8.2 times 10 to the negative 8 newtons. All right. So our force here has units of newtons. We can also check our units by doing some unit analysis. So we are left with, a mistake, an error on my end. Did you guys spot the mistake? I hope you did. Right? Here we have r squared. I forgot to square my r in the denominator. All right, so now if we crunch those numbers, we end up getting this here. Okay, so hopefully you guys caught that. Now we can do some unit analysis, right? So we've got newtons times meters squared over Coulomb squared. Here we're left with Coulomb squared. And we divide by meters squared. So doing a little unit analysis, these meters squared cancel out, these coulombs here cancel out, and we're just left with newtons, as we expect. Right? So it's a good thing that I actually went over and checked my units, because or else I would not have noticed I made that mistake. Luckily, when I did this calculation here, I did take that square into account. Now, if this problem had asked for direction as well, so maybe perhaps it asked just for us to determine the force that perhaps the proton exerts on the electron, all right, this force is attractive, so this electron feels a force in the direction that is towards the center of the atom. Right? We can just state the direction in that way. That's how we do that. If in dealing with negative signs and positive signs with this formula here, I definitely recommend that you always calculate just the magnitude of the force. All right, so just dealing with plugging in positive quantities for Q1 and Q2, and then think about the direction afterwards, right, just separately. Very similar to what we did with the gravitational force. We thought about the direction of that force after the fact. All right, so very similar here. All right, thank you guys.